The exam 3 walkthrough for the course MA158 for fall 2022. Let's begin. Number 1, find the reference angle theta r for the angle theta equals negative 5 pi over 6. So when we're asked questions about angles, I really like to draw a picture. It helps me see what I'm doing a lot better. So if we draw just your coordinate axes and we draw negative 5 pi over 6, we know that negative angles go the opposite direction, so they go this way. We know that negative 5 pi over 6 will end up in the third quadrant because this is pi over 2, and so negative 5 pi over 6 is less than pi, but greater than pi over 2, so that's why we'll end up in the third quadrant. We can see that from here then, there is pi over 6 to the x-axis, making our reference angle pi over 6. Again, if you want to do this mathematically, pi plus or minus 5 pi over 6 equals pi over 6. But again, if you draw the picture, you can see that the reference angle, or the angle away from the x-axis, is pi over 6. Number 2, solve the following equation for the exact value of x. So when we look at this, we have two exponents, but if you look at the answers, there's a lot of natural logs in here. You can see them pretty much in almost all of the answers at this point. So we can probably assume to start with the natural log. So we start with the natural log. We get natural log of 2, 3x plus 17. You got to do it to both sides to keep it equal. So natural log of 9x minus 12. So if you know your natural log and log rules, you know you can take out these exponents and put them in front. So we get x minus 12 times natural log of 9, and then 3x plus 17 natural log of 2. Now we can distribute, so that will give us 3x ln of 2 plus 17 ln of 2 equals x ln of 9 minus 12 ln of 9. We did this so that we can group these terms with x in there to isolate the x. So now we want to move all the terms with x to one side and all of the other terms to another. So 3x ln of 2, and then we move this one to the other side, so that would be minus x ln of 9. And then we have negative 12 ln of 9. We want to move this one to the other side, so that will be minus 17 ln of 2. Now we can see we can take out the x from here because it's a common term. So we have x 3 ln of 2 minus ln of 9 equals negative 12 ln 9 minus 17 ln 2. Now we can divide this side by 3 ln 2 minus ln of 9 to isolate the x to get our answer. So x equals negative 12 ln of 9 minus 17 ln of 2 over 3 ln of 2 minus ln of 9. So when we look at our answers, we can see it's pretty close to what f is, but there's a little bit of a sign difference in the numerator. However, we can take out these negative signs right here to end up with the answer that they want, which is x equals negative 12 ln of 9 plus 17 ln of 2 all over 3 ln of 2 minus ln of 9 with the negative taken out. So that gives us an answer of f. Number 3. Which of the following is equivalent to the expression e to the 2x plus e to the negative x, the whole thing squared? So I think the easiest thing to do is to write this out as the two identical terms. So e to the 2x plus e to the negative x, 8x, times e to 2x plus e to the negative 8x. If we distribute, let's see what happens. So if we distribute these, you would get e to the 2x plus 2x, and then this to this, plus e to the negative 8x plus 2x, and then this to this, so that's again plus e to the negative 8x plus 2x, and then this to that would give us plus e to the negative 8x minus 8x. Now, if we simplify the exponents on all of these, we can simplify our answers. So that would be e to the 4x plus e to the negative 8 plus 2 is negative 6x, plus e to the negative 6x, plus e to the negative 16x. Simplify this one more time, e to the 4x, plus 2e to the negative 6x, plus e to the negative 16x. And that gives us, looks like, an answer of B. When multiplying exponents, like these two, so let's say you have something like x squared times x cubed, you would add these. So that would be x2 plus 3, or x the fifth. But if you have x, let's say, squared cube to the cube power, you will multiply, so it would be x 2 times 3, which equals x to the 6th. So be careful when you're doing problems that have something to do with exponent multiplication. Number 4, determine the point P of xy on the unit circle that corresponds to the angle theta equals pi. So this is kind of a really common angle, but again, I want to draw my coordinate axes to make this easier to see. If I draw my coordinate axes, we're looking for where the angle theta equals pi. If we know that all the way around in a circle is 360 degrees, or 2 pi, then we know that pi equals 180 degrees. Now, if we draw that 180 degrees here, right, we would see that pi occurs right here. Or the angle in radians would be pi, which would be all the way on the other side. Now, when we're doing unit circles, everything has a unit of 1 on the coordinate axes. So we can see that theta equals pi occurs at -1, 0. Again, because it is on the x-axis pointing in the negative direction and there's no height, so the x value must be -1. That gives us an answer of e -1, 0. Number 5. Find the inverse function for f of x equals 8x plus 17 over x minus 22. So when we find inverse functions, we want to basically switch x and y. So let's go ahead and do that when we plug into this equation. So we would get x equals 8y plus 17, y minus 22. I'm going to go ahead and move the y minus 22 to the other side. So x, y minus 22, 8y plus 17. Now I'm going to distribute. So that gets xy minus 22x, 8y plus 17. I want to move all the terms with y to the left side of the equation so that I can isolate my y's. So that gives me 8xy minus 8y equals 22x plus 17. I went ahead and moved this term to the other side to keep all my y's on one side. Now we can take a y out so we can isolate it. So we get y times x minus 8 equals 22x plus 17. And then we can divide out the x minus 8 to isolate that y to find our inverse function, which gives us 22x plus 17 over x minus 8. Let's go ahead and look at the answers options. It looks like this option matches the answer of D, 22x plus 17 over x minus 8. Number 6. Find the domain of the function ln of x squared minus 5x minus 50. So with natural logs, whatever is inside this natural log cannot be less than or equal to, less than 0. So basically we want to set whatever this is equal to 0 to find the domain. So x squared minus 5x minus 50 equals 0. So if we factor x, common factors of 50 include 1 and 50, 2 and 25, and then I think 5 and 10 is probably the next most common one. Well, we want our signs to match here and here, so I think this 5 and 10 will work out, because if you add negative 10 to 5, you get negative 5, plus negative 10 times negative 5, or negative 10 times 5 is negative 50, so the signs work out. So we want negative 10 and then plus 5. So that's still equal to 0. when we solve for x, we get x equals 10 and x equals negative 5. Now, these are the two values where natural log of x squared minus 5x minus 50 is equal to 0. But that doesn't really tell us much about the domain. So let's go ahead and draw a number line to help with this. I'm going to put my points negative 5 and 10 here. Now we just need to see where on this number line the function is, or the inside part, the x squared minus 5x minus 50 is less than 0. So I'm going to go ahead and pick some points. Let's do 0, 12, and negative 6. So with our handy dandy calculator, we can start with negative 6. So let's do negative 6 squared minus 5 times negative 6 minus 50. So if I plug that into my calculator, let's see. Six squared is 36 plus 30 minus 50 is 16. So this is positive. So this part will be part of the domain then. And then let's do 0 here. So that would be 0 squared minus 5 times 0 minus 50, which equals negative 50. This is negative, so this part can't be part of the domain. And then let's do our 12. 12 squared minus 5 times 12 minus 50 equals, so that 12 squared is 144 minus 5 times 12 minus 50, which equals 34. So this is positive. So this is included in our domain. So wherever is positive is in the domain, because again, we can't have numbers less than 0 in our natural log function. So if we look at this, we can see that this first part is negative infinity to negative 5. And the second part over here is 10 to infinity. Again, the negative 5 and the 10 are the roots, or where the inside function equals 0. So if we look at our answers, negative infinity to negative 5 and 10 to infinity matches up with the answer of D. Number 7. Solve the following equation for the exact values of x, where ln x squared plus 10x minus 52 equals ln 2x plus 10 plus ln x minus 4. So the first thing that immediately stands out to me is this plus sign right here. With our natural log rules, if two things are added, logs or natural logs, we can say that this equals natural log of a times b. So the first thing I want to do is combine these two terms right here. So I'm going to keep the left side of the equation the same. But the right, I'm going to add them to, or multiply them together. So it'd be 2x plus 10 times x minus 4. Now, I notice that both of these have a natural log now, so we can raise all of this to the power, or e to the power of all of this to remove this natural log. So we're now left with just the polynomials, x minus 4. So again, raising e to the power of this and this other part on both sides gets it so that the left side is x squared plus 10x minus 52, and the right side is 2x plus 10 times x minus 4. Now I'm going to go ahead and distribute this right side. So 2x squared from this, and then 2x times negative 4 is negative 8x, and then plus 10x, and then minus 40. If I simplify this a little, we get 2x squared plus 2x minus 40, and that whole thing is still equal to the left side of x squared plus 10x minus 52. Now, if we move all the terms to one side to set it equal to 0 to find the roots, I'm going to go ahead and move the left side to the right side because I want this first term to stay positive right here. So 2x squared minus x squared is x squared. 2x minus 10x is negative 8x, and then negative 40 minus a negative 52, so negative 40 plus 52 is 12. Set this equal to 0. Now we have to find the roots. The roots, if we factor our x, we can put our x's here. what looks good to me is that this has a positive, so both of our factors need to have the same sign. So common factors of 12 equals 1 and 12, 2 and 6, 3 and 4, and the middle two, 2 and 6, add up to be 8. So let's go ahead and put those in, -2 and -6. So that means our x equals 2 and 6. But don't be fooled, we still have to check our answers. So let's make sure that both of these values don't result in a value that doesn't exist. So let's start with 2. If I plug it into either side of the equation, I'm going to go with this right side here. We have ln of 2 times 2 plus 10 plus ln of 2 minus 4. So this is ln of 4 plus, so 14 plus ln of -2. This does not exist, so 2 is not an answer. Let's go ahead and check 6 too. So ln of 2 times 6 plus 10 plus ln of 6 minus 4, so that gives us ln of 2 times 6 is 12 plus 10 is 22 plus ln of 2. This is good, so our answer is x equals 6. Again, whenever we have natural logs, we really need to check for if whatever's inside is greater than 0, because then if it isn't, then we have a answer that can't exist or is invalid. Number 8, carbon-14, C14, has a half-life of about 5,000 years and is used to determine the age of carbonaceous, oh gosh, that's a hard word to pronounce, materials up to 60,000 years old. It decays according to the formula A of t equals A naught e to the kt, where AT is the amount of C14 remaining after time t. A naught is the initial amount and K is the decay constant. How long will it take in years for 30% of the initial amount of C14 in the sample to remain? Round to the year's nearest year. So when we look at this equation, right? The first thing we notice is that we don't know what this k value is. With these problems, if you don't know what the k value is, there's usually an initial value hidden somewhere in the problem statement, and it is in fact right here. It says carbon-14 has a half-life of about 5,000 years. That means that A of t will, or A of 5,000 years will equal half or 0.5 of A naught. So if we go ahead and plug this in the equation, we can see that we can say A of t, or we say A of t equals this, so 0.5 A naught equals A naught e to the kt, where in fact t is 5,000 years. Now, if we divide these to cancel them out, we get 0.5 equals k times 5,000. It's a really sloppy 5,000. And now we can take the natural log to lower this down. So the natural log of 0.5 equaling k times 5,000. If we divide ln, the natural log of 0.5 divided by 5,000, we end up getting that k equals negative 1.386 times 10 to the negative 4. I don't think anything more than 3 decimals is super necessary for this. Just keep in mind, the more sig figs you have, the more accurate your answer is. Now, back to the question, is asking for when 30% of the initial amount remains. So we can say that A equals whatever time, we don't know what that is, equals 0.3 A naught. If we replace this back in the equation, we get 0.3 A naught equals A naught e to the k. The k is now negative 1.386 times 10 to the negative 4 times t. Now we can cancel the A naughts out, and we can take the natural log of both sides to again get the t to a place where we can solve it. So natural log of 0.3 equals negative 1.386 times 10 to the negative 4 times t. if we divide that negative 1.38 times 10 to the negative 4, we get that t equals 8,685 years, or an answer of F. Number 9. The population of Demogorgons in Hawkins, Indiana can be modeled by the equation d of t equals 1,111 divided by 1 plus 11 e to the negative 0.1 t, where d of t is the population of Demogorgons t years after 2016. Find the predicted number of Demogorgons in Hawkins, Indiana in 2027, round to the nearest number of Demogorgons. So, the tricky part about this question is actually knowing how many years or what value to plug in for t. So, pay attention to the fact this is after 2016, and we're trying to find it in 2027. So, 2027 minus 2016 equals 11 years. So we were trying to find the amount of Demogorgons after 11 years. So we just need to plug it back into this equation to find the amount of Demogorgons. So that's d times 11, d of 11 equals 1,111 over 1 plus 11 e to the negative 0.11 times 11. It's a lot of 11s. When you plug that into your calculator, you get 259.57 years, and that is roughly 260 years, or an answer of E. Which angles are coterminal with 120 degrees? So I'm going to draw out my coordinate axes again because it makes it a lot easier for me to see. 120 degrees is less than 180, but more than 90, so it is somewhere in this quadrant right here. So we can go ahead and just start going through the answers. I feel like with this kind of question, it's a little bit easier to do that. So if we look at A, it says 60. So 60 would actually just bring you out here. So this is already wrong, so it can't be A or anything with the answer 60 in it, because that 60 degrees does not reach all the way over to the same angle, because coterminal angles basically are in the same position in the coordinate plane. So that automatically gets rid of A and E. Let's look at B, negative 120 and 60. Actually, that gets rid of that one too. Okay, C, negative 240. If we're doing negative angles, they go back in the counterclockwise position. So negative 240 would bring you actually back up to 120. I know this because if you do 360 minus 240, so basically from here back that way, we get 120. So this first value with 240 is good. How about the second value? So 480, it's getting a little messy, but 480 would be 360 plus, 360 plus another 120, which actually leads us back to the same point. We can check this again by saying 480, 480 minus 360, which gives us 120 degrees. So both of these values are good, which gives us an answer of C. Again, if you draw it out, it's really, really simple to see. So especially with this like 480 degrees here, you can see that this first one is 360 right here, and this second part right here is the extra 120 from having it go over. I actually drew that spiral the wrong way around, so let me redraw that. If I draw it the right way around, we can actually see that it goes like this. So this is 360 plus another 120, and it goes back to 120. So remember, your negative angles go counterclockwise, and your positive angles go, your negative angles go clockwise, and your positive angles go counterclockwise. So our answer is C. Again, we can check all of the other answers too, just to make sure. D, 30 and 240. Again, 30 is right here, so it can't be this answer. And also, 240 positive, when it's positive, is, let's see, 240 minus 180 is 60. So 240 will be down here, which is also not a coterminal angle. We already eliminated E, and then the last one's F. You can't, 0 is going to be flat with the x-axis, so it can't be this answer either. Number 11, convert theta equals 10 pi over 7 to units of degrees, minutes, and seconds, round to the nearest second. So we're going to start by converting radians to degrees. So 10 pi over 7. The conversion is 180 degrees for every pi radians. Because you know this is radians, the two units will cancel out, leaving you with degrees. So 10 pi over 7 times 180, if you plug that into your calculator, equals 257.14285. I did a ton of decimals. You really don't need to do this many for our radians. So the number of radians is just this first value. We take this decimal point to find the number of minutes. So 0.14285 degrees times, there are 60 minutes in 1 degree. So if you multiply this out, you get 8.5714. Again, we only want this first value for the degrees. So the 8 is the number of minutes. Now if we take this part with the decimal, we need to find the remainder, and that will be in seconds. So 0.5714 times 60 seconds per 1 minute equals 34.28, where 34 is the number of seconds. So if we wrap up all of our answers, 257 radians, and then 8 minutes, and then 34 seconds. If we look at our options, that gives us B, where there is 257 degrees, 8 minutes, and 34 seconds. Number 12. Find the value of sine theta for an angle theta that satisfies the conditions cotangent equals 7 over 8 and cosine theta is less than 0. So the first thing I would point out is that cotangent is cosine theta over sine theta, and that equals 7 over 8. Now, I don't like to look at my angles or cotangent. I think it makes it a little bit confusing. So I'm going to go ahead and flip it and say that sine over cosine theta equals 8 over 7. Now, sine over cosine is equal to tangent, so tangent theta equals 8 over 7. So, with this information, we can actually draw a triangle. However, there's another set of conditions we need to pay attention to. So, look at this, cosine of theta is less than 0. If we draw our lovely coordinate plane, we'd see that cosine is less than 0 means that it has to be in this region, the second and third quadrant, because that means that x is less than 0. Now, because this original condition right here, the cotangent equals 7 over 8, is positive, we also must say that sine theta is less than 0, because if we look at the tangent term, right, sine theta over cosine, for it to be a positive number, sine theta being negative and cosine theta also being negative makes it positive. So now we know we have to narrow it down to the third quadrant. So when we draw our triangle, which again is 8 and 7, we can go ahead and draw our triangle like it's in the third quadrant. So that looks something like this, where the x is pointing in the negative direction and the y is also pointing in the negative direction. So we're going to go ahead and draw the angle. Actually, I'm going to redraw this triangle. The triangle actually looks like this. There's a little bit of an oopsie right there, where theta's over here, because if you were to draw this arrow right here, you would see it would look like this. So our triangle looks like this. Tangent is opposite over adjacent, so that is 8 over adjacent, which is 7. And we have a triangle, so we're going to apply good old Pythagoras theorem. So 8 squared plus 7 squared equals c squared. So that if you plug that into your calculator, you get c squared equals 113, where c equals root 113. Now, we need to find where sine, the value of sine theta. If we look at this, sine is opposite over hypotenuse. So sine theta equals 8 over root 113. But I'm going to be really, really careful because we established here that sine has to be a negative value. Because, again, for cosine to be less than 0 and the cotangent to be positive, sine has to be negative. So we're going to add our negative sign here. So our answer is negative 8 over root 113. So that is E. Again, if you look at this diagram right here, you can see that the 8 is negative and the 7 is also negative because it is basically where it would land on the unit circle is in the third quadrant, which means both coordinates are negative. Number 13, evaluate tangent of 11 pi over 6. So we're going to draw the coordinate axes because with angles, we want to see what angle we're actually dealing with. So 11 pi over 6 is really close to 12 pi over 6, or 2 pi. So we know that's going to end up somewhere in this fourth quadrant. So if we draw it, we would get that 11 pi over 6 is about here. It's actually a little bit too much, but that's okay. And this angle right here should be pi over 6 to complete the 2 pi. Now, we can evaluate here with a number that we do know. So a tangent we do know is pi over 6. So we go tangent of negative pi over 6 because this is coming down. It is going clockwise, which means the angle is negative, equals, and then we have negative 1/2 divided by root 3 over 2. If we draw the triangle in the fourth quadrant, and we know that this is pi over 6, we know that this leg, the cosine leg, is longer than the sine leg, meaning that this cosine leg should be root 3 over 2, and this leg should be 1/2 over 2, and we know that's in the fourth quadrant, so sine is negative, so this means to be a negative 1/2. Again, tangent is sine over cosine, which means we get negative 1/2 over root 3 over 2, which is what we have over here. Now, if we simplify this, we get that this equals negative 1/2 times 2 over root 3. Basically cancel out the 2's, and you get negative 1 over root 3, and that gives us an answer of F. Number 14, choose the correct statement regarding the function y equals negative 10 cosine pi x. So looking at all these options, it talks about the amplitude and the period. Now, amplitudes are not negative. Amplitude refers to pretty much how much the wave deviates from the axis. So this distance is 10, this is 10, this is 10, etc., which is given by this value in front of your sinusoidal function. So all of these sinusoidal functions come in some sort of form, like this is pretty common, a cosine of the frequency times x. So the amplitude can't be negative, so it can't be A or C. Now, the next part is to find the period. The period equals 2 pi over the frequency. If we look at this form I wrote, we can see that the frequency equals pi. So the period equals 2 pi over pi, which equals 2. So it can't be B, D, or F, which means the answer is none of the above. So again, the amplitude equals 10 and the period equals 2. Okay, last question. Number 15. Find the intervals on which f of x is greater than 0 for f of x equals cosine of, this is supposed to be an x, over 3 on the interval 0 to 6 pi. So I'm going to draw another lovely graph with the way this cosine is signed. So at 0, cosine of 0 is 1, and 1 times the amplitude of 2 is 2, so we know that we're actually starting up here. So we know we're starting up here. So the first thing we want to find is the period of this function. So the period, again, like the previous problem, equals 2 pi over the frequency. The frequency in this case is 1 over 3. So if we look at that x over 3, we can separate it, which equals x times 1/3. And so this is the frequency. Now, period equals 2 pi over 1/3, which equals 6 pi. That is our entire interval, which means that if we draw it without marking this label and we say this is equal to 6 pi. So we have 1 period over 6 pi. So one period basically means when you return to your original position. Now we can see that it crosses the x-axis twice. So when we want to find where f of x is greater than 0, it's going to be this region and this region, which means we are going to have like a missing chunk of our interval. So it won't be the whole 0 to 6 pi. Now, let's go ahead and find where that would intercept the x-axis. So when you have basically an entire cycle or a period, it can be cut up into 4 chunks. So the quarter of the whole period equals 6 pi over 4, or 3 pi over 2. So we know that this first point is 3 pi over 2, and then if we add another quarter, it would be 6 pi over 2, or 3 pi. So this middle would be 3 pi, and this last one would be 6 pi over 2 plus another quarter, which is 9 pi over 2. So this last point is 9 pi over 2. Again, when we have a full cycle or full period, it has 4 different like quarters or stages. We can show this again by using the unit circle if we want, where the end of 1 quarter would be here, so that would be where cosine equals 0. Another period would be here where cosine equals -1. Another one would be here, cosine equals 0, and then over here where cosine is back to equaling 1, and you can see that in the graph where cosine equals 0 at the first quarter and the third quarter. Now, if we want to write this in the form of the answer, we can see that f of x is greater than 0 from 0 to 3 pi over 2 and 9 pi over 2 to 6 pi. So that gives us an answer of A.